right, welcome to Unit 1, Lesson 4. This is the second video, and hopefully we're going to finish this. All right? We continue where we left off at, using the vertex form of a quadratic to graph a parabola. If you want to, pause this now, do this work, then hit play and see if you got it right, because I think some of you are really starting to get this. We'll start with my vertex. That's H and K. Let's not forget, we always flip the H. So instead of -1, it's +1 and 3. My concavity, which way is my graph or parabola opening, up or down? This one is going to be opening down since my A value is less than 0. That's this number right up front here. All right, that's my A. Next, what is my axis of symmetry? That is always the x value in the vertex. All right? How do we figure out our y-intercept? Don't forget, we set x equal to 0 and solve. So I'm going to take this whole equation here, this whole expression, -2 times, I put a 0 in for my x, -1 squared plus 3. If I put that in the calculator, if I square -1, I get a +1. 1 times -2 is -2 plus 3. That would give me a +1. All right? So before I even talk about my transformations, let's plot what we have already. Our vertex is at 1, 3. That's my vertex at 1, 3. All right? I know it's opening down, and my axis of symmetry is right at x equals 1. That's my axis of symmetry. All right? My y-intercept is at 1 on the y. Here's y1 right there. So it's going to go through this point, and that same point is going to reflect over that dashed line, or axis of symmetry. Now look at that. It indeed does open down. So the last thing I'm going to do is, this was old school, our transformations. This is something we were doing before you even realized that this is the vertex form. We would get a parabola like this and take a look at its movements. Okay? First, we got to do any left or right movements. That tells me I'm moving right 1 spot. Next, I need to do any multiplication. Okay? So the negation means it's going to reflect over the x-axis. That's what the negative sign means. And the 2 tells me that we're going to have a vertical stretch by a factor of 2. The last transformation I would have means I move up 3. And if you will, that's what a regular x squared looks like. It moves right 1. Then I reflect this. Okay, bear with me here if I can get this. I'm going to flip up and down boom, but that would be right here, 1. And then it's going to move up 3. Up 3. And of course, because it has a stretch by a factor of 2, it's going to become more narrow. Yeah, that's pretty good. All right, so I think you see what we're doing here. Get that out of the way. But that's what your graph should look like. Take a look at the second one, which I started the work on. But I'll erase this and say, pause it, do it, then check your work. You should know what the vertex is already. The vertex is -1, 4, because I take my H and I flip it, and I have my K. This is going to be concave down because of the negative sign here. Technically, that's like -1. All right, so my A value is still less than 0. The axis of symmetry, it's always the x value. My y-intercept, I make x equal to 0. So right there, the negation of 0 plus 1 squared plus 4. Well, this would be 1. I negate it, and I add 4. That would be a +3. So let's graph this based on what we have, then we'll describe the transformation afterward. All right? -1, 4. Here's -1. Here's 1, 2, 3, 4. -1, 4. That's my vertex. It opens down. The axis of symmetry, which I will do in yellow, that's the line that every point is going to reflect over. Well, what's the one point I have to reflect? Where y is 3. Right here. This point. It's going to reflect over the yellow line. And then it's going to... There you go. I mean, it's simple. Love it. Love the easiness. All right, well, let's talk about transformations. 1, does it move left or right? Yes, this tells me that it's moving left 1 spot. It is not going to stretch or compress because there's no number out front, but there is a negative sign out front, which tells me it reflects over the x-axis. And last but not least, I'm adding or subtracting outside. In this case, it's adding. I'm going to move up 4. And there you go, my friends. Second one, done. Now, writing the equation of a quadratic. All right? Writing the equation of a quadratic. This is one of the easiest things. If you thought what we just did was easy, maybe you didn't. This is easier because it just relies on basic algebra. First off, we need to remember the equation in vertex form. That is the vertex form, and that's what we're going to use, and you're going to see how easy it is. You'll notice that we have 5 variables. 1, 2, 3, 4. We have 5 letters here. Okay? If I do 4 of them, I can put a letter in for 4 of them and just solve for the 5th one. And that's exactly what we're going to do. All right? Let me explain. First off, this graph is kind of poopy. Here's the y-axis right here. So it goes up. That's the y-axis. And here's the x-axis, in case you couldn't tell. All right? Now, what I see here is they give me this point right here. That is the vertex. That is -1 on the x. Looks like -3 on the y. So -1, -3. That's my h, and that's my k. I actually have 2 of those variables right there. My k is -3. But let's not forget, my h always has to flip, right? When I put something in parentheses, I have to flip the sign, just like if I were to take it out. So instead of having -1 here, that goes in this +1. How else can I think of this? Well, I'm technically subtracting -1. That's why I would turn to +1. Okay, I am subtracting the -1. But if that kind of confuses you, which it shouldn't, you should be okay with that. Just know, anytime something goes into parentheses, you flip it. Anytime it comes out, you flip it. All right? So, I have 2 variables done, my h and k. I have 3 variables left. I have a y, a, and an x. All right? If I would get 2 of those 3, I would be all set. And guess what? I can. I'll use purple. They give me this coordinate right here. That happens to be a 1 on the x and 5 on the y. That's actually an x and a y coordinate, right? An x is 1 and a y is 5. All I need to do is solve for a. That's it. I literally replaced 4 of the variables, and I'm just solving for 1. So let's do this. Let's do this out. 5 equals a. 1 plus 1 is 2. And I need to square that. So that's times 4. And I still have my -3. Okay? So it's 5 equals 4a minus 3. You see how easy this becomes? Let's add 3 to both sides. 8 equals 4a. And if I divide both sides by 4, my a equals 2. Easy. Now we are not done yet. We still need to write the equation. Once you have your a value, all you do is put a, h, and k in your formula. How come? Because every time we have an equation, we need an output, which is a y, and we need an input, which is x. So we always need our independent variable x and our dependent variable y. So I'll leave it y equals a, which we now know is 2, times x. We have our h and k right here, plus 1 squared minus 3. I mean, that's literally it. So what I basically did is I took this spot, whatever my a was, I put that in, and I just kept my h and k. Okay, wow, that's weird. And that's it. I still need to put my y back in for 5 and my x back in for 1. That's what I mean. We always needed an x and a y in our equation. That's it. You plug in those 4 values and solve for a. And then once you get a, you just put your a, h, and k back in, and you're good to go. Before we get started on this one, before you hit pause, here's the vertex, and I want you to use this point right here. But mister, what about that point right there? I mean, you can, but I like working with smaller numbers, and -2 seems to be a lot smaller than -4. So those are the 2 points. If you want to pause this and work this out, go right ahead. I'm going to do it right now. We have -3, -2 is our vertex. That's my h and my k. So right now I have x plus 3, because I flipped the h, -2, and that's my k. Now I had another point here. That's -2 on the x, 0 on the y. All right. So this, we have -2 on the x, 0 on the y. I just need to solve for a, and I can get this equation. All right, let's do this. This will give me 1, and 1 squared is 1. Okay, so it's a times 1 minus 2 equals 0. So 0 equals 1a. Yep, that's okay. 0 equals 1a minus 2. Add 2 to both sides. 2 equals a. It doesn't always work out that your answer will be 2 for a. That's coincidence. Now let's just put our a, our h, and our k in the equation. We're done. So y equals a, which is 2, times x minus h. So I got to flip that. Plus 3 squared, and then we have our k, which is -2. H, k. The hardest part is the algebra here, and that is very simple algebra. All right, if you want to pause this, go right ahead. If not, here we go. Our equation. Vertex form of a parabola. We have a vertex right here at x equals 2, y equals 3. So we're at 2, 3. That's our h and our k. So my h is +2. I'm going to make it -2 squared. And my k is 3, so I'm just going to add 3. Well, we have 2 points here. Let's go ahead and use this one. Just to put some numbers in there. Okay, that point is at 4, 7. So that's 4, 7. That's an x and a y. My y is 7. My x is 4, and I've got to solve for A. I mean, that is it. So, this is 2. 2 squared is 4. So that A times 4 plus 3 equals 7. How do we write that? I'm going to rewrite that now. 7 equals 4A plus 3. All right, subtract 3 from both sides. 4 equals 4A. Guess what? A equals 1. Nice and easy. All I've got to do is plug A back in the equation with H and K. So, Y equals A, which is 1, times X minus 2 squared plus 3. I do not have to write this 1 here. If your equation just looks like this, you're fine. You do not have to write a 1 if it's in multiplication. Okay? Boom. There you go. Nice. This one is a little bit more challenging. How come? Because the numbers are bigger. That's it. But we have calculators, and we'll go ahead and use our calculator. All right? So if you want to pause this, go ahead. If not, I'm about to rip right through this. Y equals A times X minus H squared plus K. All right. I have this point, which looks like a vertex, and it is. This is my H. That's my K. So it's minus 20 squared plus 800. All right? My other point, I'm going to go ahead and tell you, use this coordinate right here. That is at 30 on the X, 600 on the Y. So 600 for Y, 30 on the X. I just need to solve for A. All right? Let's do this. 10 is 30 minus 20. I got to square it, it's 100. Times A plus 800 equals 600. All right? Now, I'm going to rewrite this. 600 equals these two multiplying, and I get 100A plus 800. Now, at this point, I can't tell you what A is yet until I solve. But look what the parabola does. It opens down. Anytime a parabola opens down, we should get a negative A value. You might not know the exact number, but if you come up with a positive A value, you should know something's wrong. If A was positive, this parabola would open up. It opens down. So let's make sure we get a negative A value. If I subtract 800, and I think that's going to do it, negative 200 equals 100A. And if I divide both sides by 100, I do in fact get a negative A value. I'm to the point where I just need to substitute my A, which is right here, and my HK into my equation. Y equals A, which is negative 2, times X. Here's my H and my K, right? My H is 20. I'm going to negate that. I'm going to flip it, plus my K, which is 800. There you go. Not too bad, just bigger numbers. If you needed to use a calculator, go right ahead. If you're one that struggles with basic algebra, you should be using a calculator to check yourself along the way. There's no shame in taking an extra minute to get a problem right. Okay, this is the last one, example 2. The picture shows the jump of a dolphin. Look at that. What quadratic function models the path of the dolphin's jump? Okay, this graph here, let me see if I got this here. This graph here shows, okay, the quadratic jump. Just make that a little bit bigger and move this kind of out of the way right here. All right. You have a vertex. I'm going to call it right here. That's at 3, 7. And then I'm going to have you use the points. Oh my goodness. Let's call it 9, 4. I want you to use this point right here. In case you cannot tell, this graph goes like this, to this point right here, bang. All right? So I want you to use the points 3, 7, and 9, 4. All right? If you want to pause it, you go ahead and try to figure it out, go ahead. If not, I'm about to do it. Here's your H and K. Here's your X and Y. Our equation is Y equals A times X minus H squared plus K. You will see that I write it every time. I do not need to write it every time, but it's a way for me to organize my thoughts and see my thought process. And it's easier if I make a mistake to see where I made a mistake if I'm writing down my steps. All right? Well, Y is 4 equals, I'm solving for A. X is 9. Okay, my H is 3, but I gotta flip that squared, and then my K is 7. All right, well, let's just solve for A like we normally do. All right, so 9 minus 3 is 6, and I gotta square that. That's 36 times A. I still have my plus 7, and it all equals 4. All right, I'm going to rewrite this now. 4 equals 36A plus 7. And now I'm just going to do some basic algebra. Subtract 7 from both sides. Negative 3 equals 36A. I'm going to scroll down here a little bit. And divide both sides by 36. And I get negative 3 over 36 equals A. Well, I can reduce that. I know 3 goes into both of those numbers. So ultimately, it equals negative 1/12. And that's what I'm going to use. It would not be wrong if you used this, but you should know how to reduce a fraction. Stop. Now, my A value is negative. Does that seem right? Yes, because this thing opens down. So it should be negative. That's good. Let's just plug our A, our H, and our K back into the equation. So get Y equals my A value, negative 1/12 times X. I flip the H value squared, and then I have the K value. I mean, this really is not crazy at all. And I like the fact that it gave us a fraction. Because when my students did this, they're like, I don't know if I got this right. And I would go over there and check their work, and I say, what do you think's wrong? And they're like, and their response to me is, I got a fraction. Yeah, fractions are numbers too. They can be used in equations. I would look at their work, I'd be like, that's right. They would look at me like, you sure? Yes, that's fine. A fraction is absolutely okay. We're done with Unit 1, Lesson 4. Maybe I'll see you for Unit 1, Lesson 5.